Hello mathematicians. We're now going to have a look at trig functions of a general angle. In other words, we're going to move on from being limited to right angle triangles and open up the possibility of looking at angles which are larger than 90 degrees and therefore non-right angle triangles. And we do this by thinking about a unit circle. So if we consider our triangle inside a unit circle, and a unit circle is this, x squared plus y squared equals 1, then we can see our triangle will have a hypotenuse of length 1. So if theta is the angle here, so the angle compared to the horizontal or the x-axis, then we have that for theta, sine of theta is the opposite over the hypotenuse, so y over 1, which is just y. Cos of theta is adjacent, x over the hypotenuse, and tan of theta is opposite over adjacent, y over x. And this then becomes a more general version of the trig ratios. So we're just going to have a quick look at the unit circle on GeoGebra and link that into something that many of you will already know, and that is the fact all angles in the first quadrant are positive. In the second quadrant, only sine is positive. Now, some of you may not have encountered the next two quadrants, but in the third, tan is the only positive ratio, and in the fourth quadrant, cos is the only positive ratio. So, let's have a look at our unit circle. So here's our right angle triangle, just here, and we can see that at the moment theta is an angle of size 44.44. Don't know whether we can just adjust that a little. Make it exactly 45. No, I can't. But very close to 45, so sine theta is the y value, so the y coordinate of this point is 0.7. The x coordinate of this point is 0.71, so if it was exactly 45 degrees, we know these two values would be exactly the same. And then tan theta, tan of effectively 45, we know has an exact value of 1, sine divided by cos. Now, if we move the point in this first quadrant, we can see that the sine and the tan and the cos value change, but they're all positive. There's a little bit of a problem which we'll come back to later on at 90 degrees because one side disappears, but when we move over into our second quadrant here, we can see that the sine value is positive because sine theta depends on y, and the y value is always going to be positive here, but the cos value is now going to be negative because the length of this adjacent side will always have a negative value. Oh, sorry, not the length of the side, the x coordinate of that side will always have a negative value. And then because tan is the y value divided by the x value, we're dividing by a positive by a negative, so we'll get a negative for this as well. Now, if I can fluke it to get to a nice number, I'll try for 150. Pretty close. So at that position there, sine of theta at 150 is a half. Now we should recognise that as the same value as sine of 30, and therefore we can see that if we're measuring 150 out here as the angle, that corresponds to an angle of 30 degrees inside the triangle. So when we say that we're trying to find sine of 150, what we're really doing is finding the sine of 30 in the second quadrant. And we always measure these angles with regard to the horizontal. Now, if we keep going and get into the third quadrant, then in the third quadrant we can see that the y-coordinate is now negative, so sine is negative. The x-coordinate is negative, so cos is negative. But because tan is sine divided by cos, the two negatives divide to give a positive. So in our third quadrant, tan is always positive. And we go through here into the fourth quadrant. In the fourth quadrant, again, the y-coordinate is negative, so sine is negative. The x-coordinate will always be positive, so cos is positive. And tan, because it's the negative y divided by the positive x, will always be negative. So as we go through here, we look at that pattern. So all ratios positive, sine ratio is positive, tan ratio is positive, cos ratio is positive. And we're always measuring the angle with regard to the horizontal. Now I'm going to skip quickly through the rest of this because it is just reinforcing or saying more formally what we've just had a look at. So in our second quadrant, sine of the angle theta in our second quadrant is equal to the y value of the point, and that is equivalent to sine of 180 degrees minus theta. So as we've said before, it's the angle in the triangle with regard to the horizontal. So in the first quadrant, while all trig ratios were positive, only sine is positive in the second. In the third quadrant, only tan is positive. And again, when we're looking at an angle going from here around, we're interested in this bit, which is 180 plus theta. And finally, in the fourth quadrant, only cos is positive. And we're looking at, for an angle all the way around to here, 360 minus theta. Again, the angle with regard to the horizontal. Now, in our example here, we're going to build on the fact that there's nothing special about the unit circle. So it could have been any circle of radius r. The unit circle just gave us nice, simple expressions to work with. So how do we apply that to these problems? So write down the values of the 6 trig ratios. We're only going to do the 3 rather than put 1 over all of them for the angle theta in each diagram. So in our first diagram, theta is this little bit here. So we imagine our triangle here. So sine of theta is again the opposite, so the y value over the length of the hypotenuse, and you can see that the length of the hypotenuse, because this is a circle of radius 5, that will be 4 over 5. So sine theta is 4 over 5, cos theta is 3 over 5, and tan theta is y over x, so 4 over 3. In our second example here, the angle theta is this one, which is really therefore this. So we can imagine our triangle here. So sine of theta, we expect to be positive. So it's the opposite side, which is 3 over the hypotenuse, which again is 5, because that's the radius of our circle. Cos of theta is the x, which is negative as we expected, and tan of theta, because it's y over x, or sine over cos I should say, is going to be minus 3/4. In our next problem, we're looking at that as theta, so we imagine our triangle with the angle being 180 plus theta. So in this case, we know that we only expect tan to be positive. So sine theta is minus 2 over root 5 this time, the radius. Cos theta is minus 1 over root 5. And tan theta is going to be minus 2 over minus 1, which is plus 2. And in our fourth example here, we're talking about this angle, which is 360 minus that. So again, sine theta is going to be the y value, which is minus 5 over radius. Cos is plus 12 over the radius, so it's the positive ratio here, and tan, because it's sine over cos, is minus 5 over 12.